Hey everybody, this is Larry. This is day 26 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe, and join me in Discord. So whenever I do a long video, I usually just do another intro so that you can see what is up with the situation. And for this one, it's just a lot of case analysis, to be honest. And from that, it's not hard, but I took a long time because I just couldn't come up with all the cases. So there are two observations, or actually let's make this three. These three observations is what you need, and then now for every quad, it needs to have even number of zeros and ones. I'll talk about it. I'll explain all this, but first you need a certain number of 0 and 1s in each row and column. That makes sense. Like if you have 10 ones in one row and n is 10, then you already have too many ones and there's no way to swap them around, right? Because of this value, every out of place row and columns will be matched. So this is basically just that if a certain row is not in the right place, then if you swap them, that means that you need to swap one of them, right? Meaning that if there are 5 rows that are out of place, then you need 4 swap to get them into place, right? So this gets smashed pretty, yeah, roughly speaking. And then now for each quad, there's the even numbers of zeros and ones. What I mean by that is that so let's say you have I think there was a good example here. But basically the idea for this part is something like, okay, you have right? And then now, now even though this has 2 ones and zeros in every rows and columns, this is actually an invalid board. The reason is because if you look at some subsets, like this 0, this 1, this 0, 0, let's zoom out, right? If you zoom out, this becomes 0, 1, 0, 0. And the invariant in this problem is that when you swap, no matter what, you're going to have this as the sub rectangle or sub square, if you will. And because of this property, this will always hold true because when you swap, at worst you're just going to change it like this, or there'll be 3 zeros to 1 1. And in a chessboard, that's just not a possible thing because you can only either have, either they're all the same color, or you have 2 of these, right? In some way, because you could swap them out later. Obviously, this one is the good one as well. But yeah, and knowing those 3 observations, you can do all your checks. And I spent a long time just messing around, to be honest. And you can watch me do this live next. But that's basically the idea. The first thing is that I just I count the numbers of zeros and ones. If there are too many zeros, too many ones, then it's not possible. Here I check the number of rows and columns and how much they appear. It's a little bit long. It's maybe even unnecessary, but basically saying that, okay, if there are too many ones or zeros in certain rows, then just get rid of it. That's basically the idea. And here, this is what we said about earlier with the four corners thing, because for those corners, the parity never changes. So it has to be either 0, 1, or either there's 0 or the 4 zeros, there are 2 zeros or 0 zeros. So that's basically all the possibility. And then otherwise, after that, we count the number of swaps needed by looking at the first row and first column. If it's even, then it doesn't matter which one is zeros and which ones are ones. So then we take the minimum of either the number of 4 swaps or the n minus that. N minus that being that it would be the other color, right? And same thing, and they're independent, so you could do the rows and the columns, minimize them, and then do that. If it is odd, then you're forced, because if the number of wrong rows is odd, that means that you just have the wrong color on that to begin with, so we have to change it to n minus. You have to change it to the other color, right? Flip it the next one. I think this explanation is a little bit fast and a little bit short, but I kind of catch the bus. I'm still in Lisbon, so stay good, stay healthy, and you can watch me do it next. Apologies for this weird video. I'll see you later. Bye-bye. Hey everybody, this is Larry. This is day 26 of the September Leetcode Daily Challenge. That means that you only have like 4 days to go or 5 days to go. I don't know, I can't do math. Oh, what did I click on? Okay. So hit the like button, hit the subscribe button, join me on Discord. I'm in Lisbon right now. I don't speak any Portuguese, so I can't really say anything. But in any case, I am on layover, so let's get this finished. Let's get this finished quickly, and then we'll see what happens. Okay, so today's problem is transform to chessboard. So you have an n by n binary chessboard. You can swap any two rows together, any columns. Okay. Return the minimum number of moves to. So the two possible things. Let's see. Man, this is a puzzler, isn't it? So basically, it's like in one move, what can you do? Just swap. What are impossible boards? I mean, this is one, but there are way more. For example, if the number of zeros or ones are too many or too few or whatever. This is a hard problem. So if you're joining me now, I usually solve these live, so you get my full live thinking commentary. But that also means that maybe a little bit slow. So watch it on a faster speed if you can. And yeah, that's my disclaimer. So don't complain to me later, please, please. Okay. So if the number of zeros and ones are the same, assuming that n is even, if it's odd, obviously, it's off by one. But how do you do it? Let me see. What are some impossible configurations? Okay, I see. So it is impossible if. Okay, so one thing that I would think about is the invariant of this problem. And the invariant is such that every row and column in the beginning, before any swaps, the invariant is that each row and column has the same number of ones. Is that true? For n is even. If n is odd, then but then it may be off by one. But so what you begin is what you end with, right? And then the swapping becomes easy once you know that. Well, is it easy? I mean, it's. My question is, do you have to calculate it? Like for example, for this one, okay, I mean, I think you can just do an n squared bubble sort type thing on both the columns and the rows, and I think that should be good because if it's not because I don't think. I mean, you can do a regular sorting as well, or not a sort, but like a thing. And in even, there's only two possibilities anyway. Oh, and then it is annoying because then now we're thinking about how permutation groups and stuff like that. I'm just okay. I think now we have a good idea of what's possible and what's not due to that invariant. It's a good start. how do you get the minimum number of moves? Because if it's Boolean, if it's like a true false answer, I think we're done. But now we're trying to figure out the min, right? And there are only two possible answers. But then like now we have to do some permutation groupie thing, which is a little bit awkward. Maybe. I'm trying to think whether the greedy is good. Well, we have to sort the row. Let's see. So, okay, so everything's either in place or not for the row. And we can think about each dimension independently because it gets sorted in the other direction anyway. And there are only two possibilities, right? It's either the first cell is 0 or the first cell is 1. And I'm not super convinced about the dimensions being independent either, to be honest, which is part of the issue. But okay, so if there are n numbers that are, oh, I see. If there are n rows and there are k things that are out of place, then you just swap them. They have to match in number because of the invariant. Well, the other thing that we talked about, which is the true conditions, right? Which means that each row has the same number of ones and so forth. So assuming that that's the case, then is it n by n always? Okay, it is n by n. So that means that for an n is equal to odd number. Okay, so that means that the number of swaps on the rows and the columns are predetermined by that. So okay, I think we're okay. But this is a very hard to logic proof problem for me anyway. So let's see if we can program that, and then we'll go over it in a slower manner later. But basically the two observations, right? One is we need a certain number of O's and ones in each row column. And then the other one is that the other observation is that because of this, every out of place row column will be matched, like basically on a parity type argument. Yeah. Okay, let's see. So what happens if n is odd? If n is odd, I think they didn't give you any odd numbers for a reason. Let me double check this. So yeah, there are only two possibilities, of course. This or the 0 version. Right? And we can flip them, it doesn't really matter. So yeah, how weird can we make this? So let's say we swap. Right? And now we can do this. And we get from here to here in a reasonable way. Yeah, because we first and then there's only one out place on bottom. Okay, maybe I'm convinced. Let's see. Okay, so then let's count the number of zeros and ones, right? Let's just do that. look at this. Okay, right. And then now if C of 0, if is greater than 1, then we return -1. This is false. And then the other thing that we do is, for something like this, which is impossible, and also for odd, if this is, I don't think there's an impossible one anymore, right? Maybe even for evens, I think maybe this is the only thing. For example, if this is an even number, then we do something like the only possible weird configuration is maybe this. That has this, and that's really triple, right? Like, what can you? Oh, I guess. No, this. I think I'm more thinking about something like this, where this is obviously not possible. So that means that. Okay. If we'll swap all the ones for, if this is the case, then we will, we want ones to be the one that is bigger. So yeah, I mean that's, okay, and then now what are we doing? And then now we have to check each row and column to make sure that it has n divided by 2 elements. Our number one is funky. Because I think this is the one where we have to care about a little bit. Because that means that basically you have to do a frequency count of the frequency count, and that's a little bit, let's see. This is such an annoying problem. Okay. Yeah, okay. Another problem to do right before you have to leave for the thing, I guess. Okay. Let's see here. And we just count the number of ones, and then we put it into those. Don't really want to do this. Okay, is that good? And then now, okay. I mean, we'll do the columns in the same way, but I wanted to check this. If then something like that should be equal to 1. If this is not the case, then we return -1. I'll just return 10. So that we can kind of I have to put in test cases too. So this should return 10 here and maybe 0 here. Nope. Okay. Well, that's unfortunate. But we didn't do the columns, so. Oh yeah, I guess all the rows is correct here. I'm a little bit lazy today. Alright, let's see if this is working. So basically what we're doing is kind of almost like a TDD, in that we're doing these one by one. I mean, I know it's not TDD, but yeah, and then we have to also do the other wrong one. See if that works. And also we want to try odd numbers, which we do not have in this case. Let's see. Something like that. So right now I expect them all to be incorrectly good, because we don't handle odd ends anyway. But yeah, but these are the answers that we expect at the end. So yeah, so then now else. Let's see. This is a little bit messier for odd numbers. Basically, you want them to be. You want them to have two things. Is that good enough? No, because I think. I don't know. Maybe it is good enough. Find some. No, that's not good enough because. I'm trying to think whether it is forced. But maybe it is. I don't know. I don't think necessarily though. I mean, this looks good, but then now you have to check on one that is correct. I guess this one's correct, actually. But I'm also wondering if it's possible to construct a case where this is not, or this is the case, but it's not true. No, because by the pigeonhole, you're forced to. Well, if this is not true, then this is true. But there might be another case where so this is more. If we change ones to be the one with the more number, that means that there's going to be, for 3, there will be n over 1, n over 2 plus 1. I'm just thinking right now through like n equals 5 case without drawing it. So it'll be 2 and 3s. I guess so. That's a little bit awkward right there, but okay. I'll see of n. Yeah, I mean, basically, this is just really brute force type thing, but it's just thinking through the case, right? If you have more ones and zeros, then what are the things that makes it the count not good? And I think that's should be good. I didn't want to divide this because it looks yucky, but Maybe that should be good. Maybe it's not necessary, but I think it maybe is. Okay. Okay, so we're good here. And then now we're trying to get the count, right? Now that we have all this in place, then we have I think the hard part is this is so potential. The hard part is kind of I think what I said earlier about them being independent is true, but what if they both need to swap in or away from the corner? I think that's the one that I'm not super sure on. To be honest, like if you swap the first row, it changes a lot of things, right? Man, this problem is a mess. I mean, this will at most have n times 2 as an answer, but this is a hard problem. Oh, just annoying. I want to say it's forced. Because for every cell that's not in the right place, what does that mean, right? That means that you're going to swap either the row or the column. Because now basically we're saying all the compositions are right. I don't even know what column. But if you swap them from the first one, no, I guess that's okay. Okay, maybe I can go okay here. Yeah. Okay. Now I know that I'm double counting the corner. So maybe I can do it. I mean, this isn't done yet for odd numbers, but okay, it's not even done yet for even numbers. Oh yeah, I didn't check the other one, that's why. No, but this should be... It should be right. No, I guess it's not. point is 0, then this is just done, I think. Is that true? Yeah, okay. I don't know. I'm very unsure about this one, and I'm not that. I don't know. This problem is just also not super interesting, so. Okay, let's see. Okay, I mean, this is closer, but it is wrong, obviously. Why does it change it really? Let's see. Well, two things are outplay, so you need one swap. Okay, I see now. I messed up my counting. Okay. Wrong row and wrong column. Okay. This is wrong row. Column. Otherwise, it's well, it is. Okay, I mean, this is a little bit better. Maybe we don't need the minus one here. Am I happy enough to submit or confident enough to submit? I don't know, to be honest. This is a little bit tricky stuff. Alright, but I'm going to submit because I have a time schedule. Okay. Did I not copy and paste correctly? I thought that this would do it. Oh, I'm dumb. Okay, I mean, that's just silliness. Okay, is everything good? Nope, this one's wrong. Almost submitted. That is wrong. So the number of incorrect. I see. I was going to sort for this, which is that if this is odd, what does that mean? If this is odd, that means I have to change the corner. So, and this is odd, then they both are odd. Let me just print it out just to confirm a little bit. Yeah, because this 1, 1. Let's see, 1, 0. Means that we have to do both. So this one is not possible if n is 3. So okay, let's actually fix that. Basically, 0 can only be in the upper left corner if it's an even number, right? Otherwise, we do this thing. And here, if it's odd, then that 1 has to be in a corner, but it doesn't have to be this row. This has to be something like this. So if it's odd, that means that you have to swap the corner. Maybe this should be more like this. Okay. I'm not confident about this either, to be honest. But because it prints that there's one wrong row and one wrong column. Okay, fine. Maybe that's right, actually. We'll have to round this up instead. This is going to be a little bit trial and error because this is a long file. So we'll see. Okay, fine. Oh, this is such a stupid problem. Like it's there's a lot of analysis. What do I get here? I get 3, expect the answer is 1. Why is that? Let's take a look. I'm just not feeling it today. Sorry, friends. The answer is 1. Within this to here. But why do I choose 3? So this is odd. I thought we swap it to 1s. So this should look like, okay, that's actually good that that's what it looks like. But then we swapped it to this thing. And then now, what does that mean? That means, okay. That means that the 2 wrong rows, or 2 wrong columns, and 2 wrong rows, right? I might not get this one in reasonable time. Like there's a lot of these case analysis, and it's just kind of crappy problem. That's all. Like it's not really interesting algorithmically. It's just a lot of case analysis, which is why I'm struggling a little bit. Well, not why, but it's one of the, like, you know, like I don't know if there's anything I have insights to. But yeah, but this is too sparse on the top, and that should be okay. But then I don't take care of the two wrong answers on the bottom. Okay. I got 3 on the rows, because it should be 1, 0, 1. So it thinks that all 3 rows are wrong. I think it's the column that is wrong. Trying to think whether maybe I've just been thinking about this the entire way. Like, did I miss something really silly? Okay. I mean, this input actually is a good input. I'm trying to think about how to avoid it. Yeah, maybe I was just too naive in adding only tracking this. Maybe I have to look at each cell. I think that's what I needed to do. Okay, let's think about it. Yeah, right. Okay. Okay, let's do only half of this for now, and then we'll think about the other half later. Basically, okay. The number of cells that are not in place. Okay. For sub I sub j is not equal to magic. I guess it doesn't matter. We have to do both. Okay. If this part is okay, otherwise, if the cell's not in the right place, then we have to remove it, right? Let's try also the other one, maybe. Yeah, okay. I think I know what I want to do. That's why I messed up. We'll just try the black and white, I guess, or whatever. And then now, first we have to change, that's the number of rows I have to change. Maybe something like that. Oops. I don't know. Just forgot to write the if statement. Okay. Still the wrong answers there. Because for the first one, how many cells are out of place? Maybe the zeros are right, I suppose, but let's just print out. Let's just print it out. Six and 3. That doesn't seem like that would make sense. Am I like type of something? No, oh. So it's 3 by 3? No, that's not right? How do you get 6 on the cell? Almost 12 cells, then mistype some stuff. Yeah, what the? I have some typo here. This is not a great video, guys. Sorry, friends. Why is it 6 by 6 on a 9 thing? Oh, do I just no? Why is this referencing the right number? Why is it 6 by 6 on a 9? How do you get? Oh, no. Oh, okay, I guess I see it. Because I'm doing this dumbly. I think I did get the number of rows by each row. Okay. I think I was doing it dumb way. Okay. What I wanted was, I think okay. I think this is what I mean, maybe. But then I think I mixed up some concepts in my head. And then, okay. And then we basically take the min of, well, how do I do it? Okay, so then now we take the min of the something like this maybe. Sorry, not oops. Sorry, I'm on an almost 2-hour warning. This problem took way longer than I anticipated it. And I'm still not done yet. That's not right either. Okay. Let me visualize this by printing it out. Okay. So what does this mean? This means that for a two rows out of place, and 330. What does this 0 mean again? That means that nothing is wrong in the last one. That means that we should I think my original thought was more what I wanted to do. Let's go back to it for a second. I think I was just missing something else. Okay. I think there are a number of ways to do this. I don't know anymore. Sorry, friends. I'm just really tired for this problem. Okay. Okay. I think now we can think about number of cases. If it's I think okay. Yes, that's it. If this is the case, then we return. That's the number of rows you swap, or you swap with the other one. So then that'll test the 0 and 1 case, or the 2 cases, and then you just do. Else, let's see. We only do it if it's odd. Okay. And we're forced here. So Something like this, maybe. I think. So I was really close, but I think I just didn't go for the logic. But it's still wrong. So maybe I'll. Oh, I see one that was expected to be a wrong answer. Okay, let's visualize that. That's okay. See, this part, like, it's easier to debug because that means one of my logic was wrong earlier. But, oh my god. Oh my. Okay. This is wrong because I choose 1, but this is an impossible one. Oh, because all the rows and so all this stuff is true. Then I have to think about a different way to make this impossible. Okay, so let's say we sort this. What does this mean, right? I was wrong in that. What makes this not true? So this is 2 in every case, every row and column, but that does not make it good enough. Because, that's actually a good one. I don't know why. I mean, it passes all the other tests I had. How do I, what's wrong with this one then? I mean, it obviously doesn't, but there's something weird about the parity that makes it not swappable. I'm not quite sure how to represent this actually. I see. For every 4 corners, it needs to be swappable. For example, here, if we just remove some rows, this one, and then this one, and then this one, then it becomes no good because if we swap this is no good, right? But is that probably always true for the good ones? Like if we had someone like this, I guess that probably is true. That we need something where it only has, in order to swap them and hold the invariant, yeah, you need to have 2 zeros and 2, or well, 2 or 4 zeros and 1s in the, oh my, this is messy. Okay, I don't think I'm going to do a great explanation on this one, so yeah, let's see. Okay. So it has to at least have 2 zeros, or Okay. Because otherwise, it means that those three things, no matter how you swap them, that because if you have something like the invariant is that no matter where you go, you're always going to have this property, and therefore it cannot be a checkerboard. Okay, I think that's why. This is embarrassing long. This is like, okay, let's give it some minute. I don't know. This has been a 55-minute video. Yeah, that's all I have for this one because I'm probably gonna have to re-record the beginning to explain this a little bit. But yeah, that's all I have. I will see you later. Stay good, stay healthy, to good mental health. I'll see you later. Bye bye.